All right, this is part 2 of integration by parts. Wanted to try to make these videos not crazy long. So we just, in the last video where we ended, we did an integral. You can already see it on your screen that is x's and e's combined. So I want to show you another one of that has a little bit of a twist that you might, if you started looking at this first, may see the twist and kind of what I will explain more of actually in part 3 video as well. So again, your u needs to be your x's, your dv is going to be your e's, and again, that will be the same every time we have that combination of parts. Your derivative is going to be 2x, because that's the derivative of x squared, and your integral of e to the x is just e to the x. So this one's kind of nice. It doesn't have the adjustment of ones we've done before. So we're going to match these two up. So it's going to be x squared e to the x minus the integral of these two together. And here's where we have a problem. So if you take a second, look at this, maybe pause it to see. The problem is that we are now being asked to integrate something that is still parts. We still have parts that are x and parts that are e's, and we kind of are back right where we started. So this is a situation where we actually have to repeat the process. Now, if you're listening to this going, you've got to be kidding me. What would I do if it was x to the fourth? Is she really going to make me repeat this process 4 times? There are better ways. And so I want to take you through this one, just kind of using what we've just done, but I promise you, I am going to show you a shortcut so you're never having to do this more than twice. So again, the u is the x piece, the 2x, du is 2, dv is e to the x, v is e to the x. One thing you have to really watch is this minus sign needs to be distributed. So you're going to get x squared e to the x, that's from the beginning, minus these two multiplied together, so minus 2x e to the x, minus, but there's already a minus here. So you have a minus from what's in front of the entire integral, but there's also a minus in the formula. So you end up with plus the integral of these two. Now I don't have to go through integration parts to parts again. This is something I can integrate very easily. I don't need to break it up. I don't need an adjustment. The integral of 2e to the x is just 2e to the x. So my final answer for this one is x squared e to the x minus 2x e to the x plus 2 e to the x plus c. All right, so now we're going to get into some more special cases. Really, this whole video is looking at special cases of what we've done and how we can make it some different things with it. So with this one, this is anytime you have e's with trig. And I'm going to preface this one by saying it's probably going to be your least favorite combination because the process is just a little longer, which is my screen is so big with this one. So with this, it's a pretty flexible one. It works whether you let u be the e or the trig. Out of habit, I usually let the u be the trig, but I have seen students do it the other way and it works just fine. So if u is sine, the derivative of sine is cosine. If dv is e to the x, the integral of e to the x is e to the x. So it starts out as this great problem that has really no adjustments. So it doesn't look very bad to start with. So we end up getting e to the x sine x when I match those two up, minus the integral of e to the x cosine x. And we end up kind of back where we started. We have to do the same thing again with our u and our dv with this piece. I'm going to stick with the trig. So if you started letting u be the trig, you got to keep letting u be the trig. If you decided to be a rebel and let u be the e to the x, you just need to make sure you're consistent with that. Derivative of cosine is negative sine. The integral of e to the x is e to the x. So here we go. Do it again. So watch your minus sign. This minus sign has to distribute. So I have a minus e to the x cosine x minus, there's 3 minus signs. Minus from the formula of integration by parts, minus from this that needs to be distributed, and minus from this sign, this du piece has a negative. So there are 3 negatives. Again, one from the formula, one from the distribution, one from the du. So you actually do end up with a negative, and then multiply those two together, you get e to the x sine x. And this is the point when I have students that will say, you have got to be kidding me. We just worked ourselves in a circle, which we kind of did. So now this is This is what we were trying to do in the beginning. We were trying to figure out what e to the x sine of x was when you integrated it. I like to call this problem a cycle problem because it becomes like cyclic, where it's like you just kind of repeat the pattern. And I just finished saying in the previous example, I'm not going to make you go through and do this more than twice, and now it looks like I broke my promise. Here's what you do with this one. What I want you to think of is think about that the original problem, I'm going to write the original problem is over here. The original problem is the integral of e to the x sine x. That original piece that you're trying to find also ends up over here. So in the beginning, I called this an algebra integration by parts, which probably had zero meaning to you at the time. Here's what I mean by an algebra integration by parts. If I want you to think of it as like you're solving an equation. If I was solving an equation and my goal was to solve for x, and I had an x on the left-hand side of the equal sign, and I had an x on the right-hand side of the equal sign, you would, as an algebra student, you would get all the x's up to one side. Well, now our x, or our unknown, is actually this integral of e to the x sine of x. So I need to get it to the other side. So this looks very strange, but I am going to add the integral of e to the x sine x to this side. Doing algebra amidst crazy calculus. So if I have an integral of e to the x sine x plus another integral e to the x sine x, this is not crazy math, I get 2 integral of e to the x sine x. I'm going to run out of room to write my dx's. So that's what I have. My job was to figure out the integral of e to the x sine x. I have that, except for I have a 2 in front. Well, I don't need that 2 in front. So just like if I had a 2x and I wanted to know what x is, what I would do next is I would divide everything by 2. That is actually my answer. I'm going to put my plus c on the end, try to be real official here. But my answer is all of that divided by 2, or you could put a 1/2 in front, or you could put a 1/2 in front of each term. But that's what I mean by algebra. This, thankfully, is a not super common question on the AP test. I've seen maybe some setups. I do think it's helpful going to a college class that you've seen it and kind of heard about it with me. But thankfully, of all the ones we're going to do, this is the least common of the kind of combinations that show up. And it only happens with e's and sine and e's and cosine, because sines and cosines just kind of have that repetitive nature. Last one I want to do in this video is also a special type, but it's a way simpler special type. I call this a single term, which sounds, it's like an oxymoron. I'm asking you to do integration by parts, but there's only one part. It's a single term. When you have something like this, and it's very specific to certain types of integrals, your u has to be whatever this main function is. And we already have talked that if natural log is part of your integral, it has to be your u anyway. Derivative of natural log of x is just 1 over x. But your dv needs something. The only thing that's left for dv is just this dx piece, which I said before I tend to not write, and it's not usually that important. Well, in this case, it's kind of important because it's all you got. If you're integrating dx, it's like you're integrating a 1. The integral of 1, or the integral of 1 dx, is just x. So that's how we deal with a single term. It's weird. It only happens with natural log all by itself, or inverse trig all by itself. There are the only 2 times that you're going to see this single term, and you're going to have to use this technique. So then we match things up. These 2 multiply together. So you'll get an x natural log of x minus the integral of these 2 multiplied together. Well, when I multiply a 1 over x by just an x, the x's will cancel, and I'll just be integrating a 1. You put a dx at the end. If you forget, it's not a big deal. So my final answer for this is x natural log of x minus x plus c. So again, a special type way better than the special type that we went over before. This one's more common though. I have seen AP tests, because they'll even put, like, they try to sneak things like this on the AB test every now and then, which drives me crazy. But this is something they tended to ask more about. The actual long ones and the really complicated ones, they do tend to avoid or find different ways to ask it.